Let's take a look at another Temu product. Now, some of you think it may be pronounced Temu. I say Temu because that is how that combination letters would pronounce in Queen's English, as in temperature, temperamental, even tempura, which is Japanese. Anyway, these are little USB lights, and recently Temu got in touch and said, would you like to be a show for our products? And no, I wouldn't, even though they offered to put a huge amount of credit into an account and have me do lots of reviews of products and glorious things. No, because fundamentally, Temu, I'm looking for crap products, and these fit that description, and the videos I make are not going to be jolly and cheery, although I will say that Temu have been disappointing in not providing dangerous enough products for this channel. All the products have been safe. It's quite frustrating. Temu, I want more dangerous products. Anyway, we have a set of little lights here, and these were described as 5 pieces. USB small night light, mini creative portable soft light, eye care, LED small round light, available for student, dormitory children's bedside light, USB plug-in. And I chose the 5-piece option with the multicolour, and it actually says in this picture, it says one of each colour, but it lists 7 colours here. But I got 5 colours, red, green, blue, cold white and warm white. And when they arrived, I plugged in the warm white, which looks quite nice, and it was a reasonable intensity, and it came up at 54 milliamps. And I thought, that's quite a lot if it's just the usual 2 LED system, which coincidentally it is, 2 LEDs, but strangely invisible resistors. This is important. I put the dots in these for the colour identification, and then the next one I picked up and plugged in was the green one, and OMG, it's like 190 milliamps and climbing. It's about 200 milliamps, and you think, really, does it have lots more LEDs inside? No, it's still just got 2 standard LEDs inside, and I was wondering, why is that? Well, it turns out, initially I thought there were no resistors at all. It turns out there are resistors, but they've been implemented in a specifically interesting way. I've got some other data for the other colours here, but initially I shall show you the circuit board. My apologies if my voice is croaky. I'm just under the weather at the moment, and it's been croaky for a while. So here's the circuit board. We have the 4 active pins of the USB connector. We've got 2 data pins are not connected. We've got the negative here, and we've got the positive here. The positive does 2 things. It goes to one end of a printed resistor, and it goes to one end of LED. At the other end, the negative goes to the end of a printed resistor, and then it goes to the other LED. And these resistors are actually virtually invisible because they're actually under the layer. They've been printed in the copper, and then the solder resistor has been put over the top, basically hiding the resistors. But generally speaking, printed resistors are fairly accurate because it's a very specific era. It's a very specific thickness screen printed on, and it's a very specific carbon density. That does not apply in this instance at all. Let me show you the data and the schematic. It's not a very complex schematic, but it is nonetheless a schematic. We have the USB connection. We've got plus 5 volts and the 0 volts. We've got an LED, and then a resistor, a printed resistor, and then a printed resistor, and then the LED. For the red, the resistance of the 2 resistors was 22 ohms and 25 ohms, and the current through the LEDs was 150 milliamps total, so about, well, roughly 75 milliamps each, but it's not quite as well divided as that. The green was horrific. It was 220 milliamps when it had stabilized, and the 2 resistors were roughly equal at 15 ohms. The blue, roughly 15, 16 ohms, 208 milliamps. The cold white, 18 ohms and 20 ohms, 168 milliamps, and then the warm white was the odd one out, with higher values but really random, 56 ohm and 75 ohm at 57 milliamps. So basically speaking, they've printed these carbon conductive ink resistors as part of the manufacturing process, when in reality it wouldn't have really been that hard just to place a resistor, a surface mount resistor, but this is obviously cheaper because it's just basically, it's a screen printed process. But in this instance, they've not really kept tabs on the density of carbon in their compound, or perhaps it's the screen printing has just been very random in the density they put down. However, I suppose there is a way you could salvage this situation if you wanted to get some of these? Well, apart from getting a custom circuit board made and actually putting it in, which would work, it appears that the connector is shoved through, and it looks as though the circuit board is then soldered in situation with those two end pins that holds it in position. But you could theoretically just scrub that off and put a resistor across it, a surface mount resistor, or even a through-hole resistor. But to be honest, the way it's designed, it would be better just getting a custom circuit board made. But then again, they were dirt cheap anyway. So maybe just use them until the LEDs inevitably fry, except for the warm white, which is running at a reasonable level. But really, it could be the basis if you're looking for a custom project for a little enclosure with the USB connector and a little bit of your own circuitry. That's what these could be good for. But as lights, they're a bit random. They're very unpredictable.